Okay, example 2. Find the volume of the solid obtained by rotating about the x-axis in the region under the curve y equals the square root of x from 1 to 4. So it's the same problem as the last one, except now we're going from 1 to 4 instead of from 0 to 1. Right? So if you take a look at this, y equals the square root of x again. This is not as easily graphed, in my opinion. So if I went over here, this is how I would graph it typically. And most of these, they're not easy to graph. So if you just go here and go square root of x, all right, and then go to my table. I'm going at a 0.5 interval. Again, this would be something you decide after you graph it. If you don't know what the interval you should use is, here's how I decide my interval. If I put 1 in and 4 in, that's the smallest, that's the biggest for y. All right, and I know x is going from 1 to 4. So I want to make sure x fits and I want to make sure y fits without using up an entire sheet of graph paper. So I want to half scale on both 1, 2, 3, 4, and then 0.51, 0.52. I mean, again, that's a pretty decent sized amount of space there. You want enough space that you can actually draw the circles in, put the radius in, that kind of stuff. So that's kind of what you're looking for when you're deciding an interval. So if I go 1, 1.5, 2, 2.5, 3, 3.5, and 4. Whatever interval you do pick for x, make sure you get a point for everything you pick. So everything there is there. So I got 1, 1, 1.5, 1.22, 2, 1.41, 2.5, 1.58, 3 is 1.73, 3.5, 1.87, and 4, 2. I missed a little bit on that one dot, but that's okay. All right, we're starting at 1, we're ending at 4, right? So x equals 1 to 4. So we're starting here and we're ending here. So my original region is this. So once I've established that, now I need to rotate it. And again, rotating about the x-axis means that our rotation is going right here. So that means that every point I got up there, its reflection is going to be down here. So it starts at 1, 1, ends at 4, 2. And it kind of goes along the way. A little bit of a curve, almost straight, kind of like that. And you don't get marked off for bad art. So you see my line got a little shaky right in here. But again, the whole point of this is that I can get a visual representation of a three-dimensional object. So the front and the back are here. And just like that, I've got my three-dimensional shape figured out. Now, something I failed to mention the first problem I'm going to mention this time. The reason I wanted to shade that region. Always draw your radius to the shaded part. Okay, so obviously the radius can go in any direction, go straight out, straight down, straight up, whatever. But if I'm considering some cross section in here, always draw your radius into the region. That's positive y is the radius. And last time I put r, what I usually put is y. So what my radius is, whatever it is. In this case, y is what the radius is. But don't ever call the radius r. Since I did call it r, I had to put r equals y up there. Either call it x or y or something about x or y. That's the better thing to call it when you're doing it. But again, always draw your radius into the shaded part. That's the reason we're shading. And again, when we start getting away from the x and y axis, that it becomes more important where the radius is going. So the radius here is y, and again, I've got my circular cross section I've got to deal with here, so I want to draw a circle to represent it. And I want to put a radius in like so. And we can see here the radius is y, but y equals the square root of x, so I want to put the square root of x here. Okay. The area formula is still pi r squared. So the area of this is still pi x, it's the same formula, so the same equation should give us the same area formula, right? So now my volume is going to equal the integral of pi x dx as we go from 1 to 4. Again, I personally like to put the pi outside. I think it's just a little nicer to look that way, but that's the area formula I'm looking at. So the volume is going to equal pi x squared over 2 as we go from 1 to 4. If I put 4 in first, I'm going to get 4 times 4 is 16, so I get 16 pi over 2. If I put 1 in, I'm going to get pi times 1 squared over 2, that's pi over 2. If I subtract, I end up with 15 pi over 2.